Welcome back to Introduction to Green Process Engineering. In this video, I will introduce you to the topic of microorganism bioeconomy. Food, energy, pharmaceuticals, and plastics are some of the most commonly used commodities in the world. The use of pesticides, herbicides, and chemical fertilizers and the release of methane and other pollutants from farms deposit harmful components on land and in water bodies. Food, energy, pharmaceuticals, and plastics are some of the most commonly used commodities in the world. The use of pesticides, herbicides, and chemical fertilizers and the release of methane and other pollutants from farms deposit harmful components on land and in water bodies. The disposal of pharmaceutical waste sludge from the production of fossil fuels and the disposal of non-biodegradable plastics destroy ecosystems and seep hazardous chemicals into the soil and water. Microbiology holds a viable solution to these threats to environmental sustainability through cleaner production and waste management. Green microbiology is driven by sustainable microbial technologies that use microorganisms to produce renewable and biodegradable biofuels, nutrients, and sustainable sources of food and biodegradable alternatives to plastic, break down harmful waste completely or into less harmful components, and produce clean and renewable energy. As you can see from the figure, microbial bioeconomy is linked to renewability, sustainability, efficiency, transparency, collaboration, and innovation. With their central position in the bioeconomy, microbial processes and products therefore have very good economic potential depending on the framework conditions and are used in areas such as agriculture, food industry, chemical industry, pharmaceutical industry, fuel economy, and constructions. They can be found in the provision of raw materials, the conversion into products of all sectors of the bioeconomy, and the recycling of residual materials. Value spectrum of the products range from low-value raw materials to high-price pharmaceuticals as presented on the diagram. The scientific competence to develop microorganisms into efficient biocatalysts and to develop and operate the corresponding technical processes and plants is crucial for the transition to the bioeconomy. In the transition to the bioeconomy, the economy should adapt to the processes of diverse raw material ranging from agricultural biomass to waste and carbon-containing gases. It is important to distinguish between the green microbiology and environmental microbiology. Green microbiology is an interdisciplinary field that studies microorganisms, their activities, and their potential uses with a specific emphasis on establishing sustainable practices, production, or deriving value from renewable resources and ecological applications. Green microbiology explores how different microorganisms can be used individually or combined to form microbial consortium that advance environmental sustainability. The components of green microbiology are often similar to the components of the fields of microbiology. Environmental microbiology is broader in scope and exploring microorganisms in their entirety, including studying microbial communities, their diversity, functions, and interactions within ecosystems. It encompasses broader investigation into microbial ecology and ecosystem dynamic, while green microbiology highlights the utilization of microorganisms to address environmental challenges and develop eco-friendly solutions. In the table, the differences between them are described. The ultimate outcome of green microbiology is achieving an optimum level of environmental sustainability. Environmental microbiology contributes to these ends through discoveries on the interaction of microorganisms with each other and with the environment. To harness the benefits of green microbiology for environmental sustainability, compliance with the guiding principles of the field is crucial. These principles include sustainability, renewability, biodegradability, multifunctionality, biocompatibility, diversity, and a collaborative approach. The role of sustainable microbiology in agriculture and food production does not end in the harvest stage of agricultural produce. Microorganisms play critical roles in food processing and in enhancing the nutritional profiles of different foods. The role of the microbes in the food industry is also in the reduction of waste. They are active in food processing and food preservation. They have environmental impact. They play a role in the nutritional connections and improve environmental sustainability through a reduction of food waste and degradable packaging. Microorganisms have and continue to play pivotal roles in the healthcare and pharmaceutical industries. Antibiotics are classified under 3 classes of microorganisms and 1 class of synthetic antibiotics. This phenomenon is used by the pharmaceutical industry to manufacture antibiotics and is the basis of research into new, more selective and high-potent antibacterial therapy to prevent drug resistance. In addition to playing a fundamental role in the manufacture of antibiotics, microorganisms are the main ingredient in the manufacture of vaccines. Microbes are used as vectors in vaccine to force an immune response in the body and prepare the host to fight similar pathogens in the case of an infection in the future. The application of microorganisms holds immense potential for promoting sustainable practices. The figure you see presents the challenges and opportunities in the application of microorganisms for environmental sustainability. These challenges and opportunities are explored in this section, shedding light on the promising prospects as well as potential obstacles in harvesting microorganisms for environmental sustainability. Cost is one of the main challenges faced in the application of microorganisms for environmental sustainability. Microorganisms provide cheap yet high effective nutritional supplements that could potentially prevent reliance on food types that destroy the environment. In this video, we learned about the microorganism bioeconomy's possibility of adding value, microorganisms' central function in the bioeconomy, differences between the green microbiology and environmental microbiology, green microbial principles, sustainable microbiology in agriculture and food production, microorganisms' roles in the healthcare and pharmaceutical industry, and their challenges and opportunities. Thank you for watching, and I'll see you in the next video.